Assalamualaikum warahmatullahi ta'ala wabarakatuh. Very good afternoon everyone. Actually I'm in morning, so you are in the afternoon, but this afternoon I have some very urgent meeting in Chupeng, so that I have to make a video for you. Okay, so today's task is only a simple task. We will need to do some tutorial on what I have given to you. Without further ado, let's go with the example number 1. Still remember this example? Okay, a gas turbine unit has a pressure ratio of 10 to 1 and a maximum cycle of temperature which is 700 degrees Celsius. Okay, I delete this up because I want you go from basic to advanced question. Alright, so this question asks, calculate the power output of electric generator geared to the turbine when the air enters the compressor at 15 degrees Celsius at the rate of 15 kilogram per second. Okay, given CP or pressure constant, not pressure constant, A constant is 1.005 kilojoule kgk, and the lambda is 1.4 for the compression part, and for the expansion part is take 1.11 kilojoule kgk, and the lambda is 1.33. Alright, so to solve this question, first of all you need to draw a TS diagram. Of course you can draw a PV diagram, but it is more difficult to you to understand the PV diagram instead of TS diagram. Okay, I recommend you to solve this kind of problem or gas turbine problem using a TS diagram, right? So on the TS diagram, it's supposed to be like this. TS diagram. T stands for temperature, we use Kelvin. Okay, S is for entropy, right? So a gas turbine unit, dia cakap ada one compressor and one turbine. Power output generator gear to turbine. Okay, ada satu compressor, satu turbine. So basically the TS diagram for gas turbine for one compressor and one turbine is just like this. Okay, just like this. So this first line referring to the pressure line. Okay, pressure line. The second line here is also referring to pressure line too, right? But the lower line is represent the lower pressure, the higher line is represent the higher pressure. So the lower line here is the low pressure. Okay, so here is the air intake. What is the air intake? Temperature 15 degrees Celsius. So you need to convert it to Kelvin Celsius, Kelvin degree of temperature. Okay, so 15 plus 273, you can get a Kelvin temperature. So here is 288.1. okay, then it has an isentropic efficiency of 0, which means a zero compression isentropy. So this is point number 2. Okay, so what is the temperature here? Okay, we will let it there first. So we will calculate the T2 later on. We need first of all, if you want to tackle this question, you need to sketch the TS diagram in the full view first. Okay, in the full view first. So the process number 3 is somewhere here, given in the question, it said that the maximum cycle temperature it is 700 degrees Celsius. So it is here 700 plus 273, 700 plus 273 equal to 973 Kelvin. It's not kilo there, but K stands for Kelvin, capital K. Okay, capital K. So we have another fourth process, which is the expansion of pressure ataupun expansion of entropy. Okay, expansion of entropy to a fourth position here, fourth position. Okay, so from this question, what do you need is actually the temperature itself. Okay, in gas turbine, most important thing is temperature in each of these point. Okay, setiap point ni kita perlukan temperature dalam unit Kelvin, not degree Celsius but Kelvin. So to find a T2 here, there's only one formula you need to memorize, which is I'm writing for you. T2 over T1 equal to P2 over P1 power of lambda minus 1 and lambda. Okay, P2 over P1 is here. This is P2, your P2, this is your P1. Okay, from the pressure ratio given here is 1, this is 10. Is it actually P1 is 1 kilopascal? Not necessarily. Is it P2 is equal to 10 kilopascal? Not necessarily, because what has given to us here is pressure ratio. It's not the actual atmospheric pressure. Okay, it is pressure ratio. So we count it as a pressure ratio. We not count it as the actual pressure on that stage. Okay, so to find the T2 here, we have a T1. Just rearrange this equation. Wait for a minute. T1 P2 over P1 and lambda minus 1 and lambda. So T2 equal to, where's your T1? Here, 288, and your P2 over P1 is 10. Lambda minus 1 and lambda, the compression part, this is compression part, this is expansion part. So compression take 1.4, expansion take 1.33. So here is 0.4 divided by 1.4. So your T2 here is, you can calculate it. I'll calculate it too. 0.4 divided by 1.4, you got 2 over 7, 10 power of that answer times 288. You got 556.04 unit. Jangan lupa Kelvin, capital K, capital K. Kalau huruf kecil K, dia mewakili kilo. Okay, kalau capital K, huruf besar K, dia jadi Kelvin, right? So you have a temperature of at T2 556.04 Kelvin. Okay, 556, sinilah temperature dia, right here, 556.04 Kelvin. Okay, and then the other one is T4. T3 you dah, soalan dah bagi, you have 973 Kelvin. Then T4, kita repeat saja the same question. the same equation. Tadi kita tulis T2 over T1 P2 over P1 lambda minus 1 divided by lambda. Okay, for the other one here on the expansion side, okay, don't write like this, G4 over G3, don't write like this, P4 over P3. This is very wrong, okay, because what given to us is the pressure ratio between P2 to P1. Okay, be remind that P2 and P1 is actually P3 over P4. P2 over P1, it is actually the pressure ratio of P3 over P4. So use the same equation like this, T3 over T4 divided by P3 over P4, P4 lambda minus 1 lambda. Okay, P3 over P4, which is actually the P2 over P1, because it is a straight line and connected. Okay, straight line and connected. So the P2 over P1 and P3 over P4 is the same pressure ratio. Take 10 here. Okay, you need T4, right? Because T3 we want to find it. So T3 is given, T4 we want to find it. Okay, so T4 divided by T3, P3, P4 lambda minus 1 and lambda. So your T4, plug in all the value, 973, 10, take 0.33 divide by 1.33. So you got T4 berapa? Let me press the calculator for you. Divide 1.33, 10 power of answer, and 973 divided by answer. You got 549.53 Kelvin. Okay, if you sketch it back your TS diagram with temperature given, you have calculated this point is 299. This point you got berapa tadi? 556, 556 Kelvin. Okay, this is temperature, this is entropy. Your T3, this is T1, T2, T3, T4. So your T4 here is 549.53 Kelvin, and here T3 is 973 Kelvin. Alright, so you complete your TS diagram. You have complete your TS diagram. So now we need to find power. If you read back our question here, calculate the power output of electric generator. Okay, dia nak cari power output of electric generator. Easily you can find the power output, the net power output here. Here is work out. From the graph you can see, you can find the work out here. This is work in, this is Q in, and this is Q out. Okay, to find the power output formula, which is power equal to m dot mass flow rate time work net. Okay, work net. So kita ada work out, kita ada work in, kita ada work net. Sebenarnya work net ialah work out minus work in. So you got work net, right? So you dah ada graph ini, you kena teruskan cari work in lah. Work in macam mana formula dia? Work in equal to CP T higher is here, sini work in, sini work out. T higher, T2 here. Don't memorize the equation. Just from my advice, memorize from the TS diagram itself. Okay, because the number can be changed. The number of 1, 2, 3, 4 can be changed depend on the question. But based on your understanding, the equation cannot be changed. Okay, so T higher tolak T lower here, T1. Workout here is CP T higher T3 minus T lower T4. Okay, so for CP on the compression part, the question asks you to use 1.005, while for the expansion part, the question asks you to use 1.11. Okay, so based on this formula, find the work in. So CP untuk compression 1.005, T2 berapa? 556 tolak 299. So you akan dapat work in. Saya kira sekejap tadi dapat lebih kurang 269. Kita balik tulis 269 kilojoule over kg. Don't forget the unit. While the CP is 1.11 for expansion, and the T3 is 973 minus T4 549.5. So you got just now 470 kilojoule over kg. So you dapatlah work in and work out. So nak dapatkan work net, tolaklah work out, tolak work in. So work net is here, work net equal to work out minus work in, lebih kurang 470 tolak 269. Dapat jawapan 201. Betul? Kilojoule kg. Jadikan dia power darabkan dengan m dot work net. M dot given ialah 15 kilogram per second. Kemudian work net kita dapat 201 kilojoule over kg. Potong kg tinggal 15 darab 201. 15 darab 201 3015 kilojoule per second ataupun kilowatt lah. Joule per second ni ialah unit dia watt. Okay, 315 kilowatt. Dapat. Okay, mudah. Sangat mudah. Again, you don't need to memorize any formula. But you need to understand the TS diagram. Where's the input, where's the output here. You better test yourself, do it yourself instead of watching here. saya dah upload kan slide ni. You do it yourself and compare your understanding to my understanding based on the TS diagram itself. Okay, you don't have to memorize any formula. You just need to develop ataupun to expand the formula from the TS diagram itself, right? And so we're done with example 1. You got around 3015 kilowatt. I guess I remove, mana pula ni tak melekat ni, sorry, need to remove this. Kenapa dia kat sini? Ok, cara dia ialah kita don't save dulu. Kejap saya buka semula. Slide here. Alright, tadi example 1 kita dah buat, sekarang kita buat example 2. Kalau you lihat, if you look closely, saya dah take off the strike through word yang dalam example 1. Sebenarnya di belakang strike through word tu ialah di sini dia ada tulis the isentropic efficiency of the compressor and turbine are 0.82 and 0.85 respectively. Apa maksud dia ni? Okay, apa maksud dia ni? Kalau saya lukis balik graf ini, okay, here we go. Ada dua line pressure yang sama, sini 10, sini 1. A intake masuk 288, saya masih ingat 288 Kelvin. Dan T2 di sini berapa tadi kita kira? Alamak, tak ada pula kat situ. T2 kita kira 556 Kelvin TS. Kemudian T3 given not dotted line but the straight line. Here is dotted line. Given is 973 Kelvin, while the T4 here is 4 3 2 1. T4 kita kira dapat 549 549. Of course kita ada beberapa titik puluhan, tapi saya make it simple so you boleh nampak rather than all those titik puluhan, awak boleh nampak the prime figure lah. Okay, so basically untuk basic question example, sepatutnya given to us is like this lah. Kita ada dapat semua temperature pada setiap proses 1, 2, 3 dan 4. But the question next step difficulty is isentropic efficiency. Soalan tu dia bagi kat kita isentropic efficiency. What is actually isentropic efficiency? Kan saya dah pernah tunjuk awak, isentropic ni actually the entropy. Okay, dia adalah entropy. Okay, bila ada entropy, sebenarnya kita jadikan dia teori ataupun ideal. Kita jadikan dia ideal. Entropy ni kita jadikan dia ideal. Bila kita cerita pasal efficiency, maksudnya kita jadikan dia actual. Okay, actual. So basically kalau you kira mengikut tak ada efficiency atau isentropic ni, basically you dapat proses dekat dalam compressor T1 to T2 macam ni lah. Kalau dia ada bagi kita isentropic efficiency, which mean the temperature exiting the compressor slightly above than what is actually ideal here. Okay, dia mesti berlaku di atas ni. Sini ialah T2 actual awak, T2 actual. Sama juga apa yang berlaku dekat compressor. Okay, ini adalah isentropic efficiency bila dia expand. Okay, sebenarnya apa yang berlaku, dia ada slightly increase of temperature dekat when exiting the turbine. Di sinilah. Okay, T4A di situ. A stand for actual, 2 kat sini ataupun dekat dalam solution yang dibagi S kan. S stand for entropy ataupun isentropic. A stand for actual. Okay, apa yang selalu berlaku? Student selalu confused ataupun dia tak tahu macam mana nak cari T2A ni. Okay, T2A. For me, simple. Kalau dekat compressor, saya always remember satu, kalau benda tu 2, kemudian dia benda tu 2 yang you perlu memorize, then benda tu hanya diterbalikkan saja, sama ada satu di atas ataupun satu di bawah. So saya selalunya akan memorize satu. Okay, for example, when minus jumpa minus, you akan dapat plus kan. So plus jumpa plus, you akan dapat plus. Ni negative sign ni dalam matematik. Kalau minus jumpa plus, you dapat minus kan. Ataupun plus jumpa minus, you dapat minus. Ni simbol sign dalam matematik, common, you pun tahu. So macam ni sama. Kalau dia dia sama, dia akan jadi positif. Kalau dia sama sign, dia akan jadi positif. Kalau dia tak sama sign, dia akan negatif. So the easiest way to memorize this thing is kita ingat satu saja. Sebab of course lah, sekarang ni you dah mahir, you dah jumpa banyak kali benda ni. So you dah boleh bezakan lah minus positif. Bila minus jumpa positif, dia akan jadi negatif. Bila minus jumpa positif, dia akan jadi minus. Bila positif jumpa positif, dapat positif. Of course lah kan, sebab you dah mahir, you dah jumpa benda tu selalu. But the thing that, kalau you tak jumpa benda tu selalu dan you nak quickly memorize it, you try to compare both equation and find the differences and make it your own rule of thumb. Okay, your own rule of thumb. Macam di sini, saya ingat kalau dia compressor, it is always isentropic di atas, actual di bawah. Okay, isentropic di atas, actual di bawah. Ni untuk compressor. How about on the turbine? Efficiency isentropic untuk turbine, kita terbalikkan saja. Actual di atas, isentropic di bawah. Okay, so dari sini, sorry, saya delete dulu ni. Kenapa tak boleh delete? Sekejap. Ada cara shortcut, tekan bulat, circle, boleh delete. Alright, macam tu. So untuk yang ini, okay, nak cari T2 kat sini, for example, based on my saya punya equation, bukan question, my own equation here. This is the compression part. Okay, yang di sebelah atas must be isentropic. So isentropic is here, T2. So higher tolak lower, temperature tetap higher tolak lower. T2 minus T1. So actual is here, T2A tolak T1. So you are looking for T2A here because isentropic compressor punya value dibagi kat sini ni 0.82. So you pusing sajalah dia. Okay, apa yang you perlukan ialah T2A. Okay, apa yang you perlukan ialah T2A. Let me write properly back. Compression T2S minus T1, T2A minus T1. kita nak cari T2A. Okay, T2A tolak T1. Ni saya buat satu-satu ni. T2S minus T1 bahagi dengan isentropic compression. So kita nak cari T2A equal to T1 plus T2S tolak T1 isentropic compressor. Okay, so T1 berapa? 288. T2S berapa tadi kita kira? 5 ataupun T2 lah, 5 6 tolak 288 isentropic compression 0.82. So you dapat T2A. Alright, you dapat T2A. Exactly the value is T2A. Kalau saya simplify, tak ada perpuluhan belakang sini, 556 ni. So I got 627.073 Kelvin. Okay, you dapat 627.073 Kelvin untuk turbine. Sama juga, you tengok balik you punya graph di sini, actual di atas. So T4 ataupun T3 minus T4A, kemudian T3 minus T4. Okay, T3 minus T4A, T3 minus T4S, S ataupun T4 lah. S ni yang sedia ada, kita dah kira. So you nak cari T4A, you pusing lah dia. Okay, you pusing lah dia. T3 T4S equal to T3 minus T4A. So you nak T4A, T3 minus all load here, T3 minus T4S. If you calculate properly, you boleh dapat lebih kurang macam ni lah, 613 Kelvin. Yang ni saya nak ringkaskan saja. Saya sepatutnya you need find at least 2 digit at the back here. Okay, 2 titik puluhan, and then you dapat T4A. After that, sama juga soalan, still asking you to find power, which is work net. So work net di sini ialah work out tolak work in, work out tolak work in. So the work out is actually T ni, work out kat sini kan, you kena ambil yang nilai actual lah, you jangan ambil nilai yang 4 yang idealnya. You kena cari yang, you kena ambil nilai yang actual. So T3 minus T4A. Okay, untuk work in, no, I forgot the CP. Okay, CP equal to T3 minus T4A, and the work in is actually CP T2A minus T1. Okay, take the A, the actual value, the actual temperature. Okay, then baru betul jawapan awak. Okay, sama. The step is almost similar to number 1. Of course, the same question, only I remove the isentropic. But now question number 2 asking you to use isentropic. So on the work out and work in calculation, you need to find actual temperature at the exit of the turbine and actual temperature at the exit of a compressor. Okay, so then you can get the work net. then you times dengan mains flow rate, you dapatlah power dia. Right, macam solution yang ada dekat sini. You akan dapat lebih kurang 1098 kilowatt. Okay, 1098 kilowatt. Next, on the question number 3, actually you dah faham basic ni, you boleh go through sebenarnya untuk question number 3. Okay, let me read through for you. A gas turbine unit takes in air at 17 degrees Celsius, 17 degree Celsius. Dari pengalaman saya mengajar dari tahun 2018, student always forget to change degree Celsius to Kelvin. You can do the process, you can calculate all the process, but the problem is the initial part of the question, forgetting to convert from degree Celsius to Kelvin, and of course forgetting the isentropy, forgetting the formula itself. Why forgetting the formula? Because it memorized the formula. You don't need, I repeat, you don't need to memorize the formula. You need to expand the formula from TS diagram you have sketched. Okay, you need to expand the TS diagram from whatever question ask you to sketch. Alright, for example, like this. A gas turbine unit takes 17 degrees Celsius air to the inlet of compressor and 1.01 bar, and the pressure ratio it is between 8 to 1. Okay, kalau TS diagram yang dimaksudkannya seperti atas adalah seperti yang you nampak dekat figure number B ni, figure B here. So dia ada dua line, pressure line. Satu di sini 1 bar, 1.01 bar, dan di atas ini ialah 8.08 bar. Kenapa saya cakap 8.08 bar? Sebab pressure ratio dibagi ialah 8:1. Okay, bar is actually 8.08 darab 10 kuasa 5 Pascal. Bar tu represent 10 kuasa 5. Okay, Pascal. And the compressor is driven by high pressure turbine, while the low pressure turbine drive a separate power shaft. Beritahu ada dua stage of turbine. Tadi kita lihat soalan ada satu stage je turbine. Di sini kita ada dua stage of turbine, satu compressor, kemudian dua stage of turbine. First stage is high pressure turbine, and the other stage is low pressure turbine. So the high pressure turbine, it is working to rotate the compressor. Apa yang output kat sini terhasil, dia gunakan untuk rotate compressor di hadapan. Okay, so isentropic is given here, given apa lagi dia minta, dia suruh cari kita calculate the pressure and temperature of the gases entering the power turbine. Ni dia suruh cari temperature dengan pressure dekat 4, T4 dengan P4. Okay, actual lah, actual T4 actual, sebab dia bagi isentropic efficiency kan. Dan dia suruh cari entering the power unit turbine the net power. Okay, work net dia kat sini je lah, work net. Dia tak ada input dari sini lah, dia nak work net kat sini saja. The work ratio, the cycle, and of course the rest lah. So the problem here kan, kita jumpa ialah dia bagi kita temperature kat T1, 17 tambah 273, 17 tambah 273. Saya tekan kalkulator kalau awak nak tahu. 290 Kelvin. Dan the higher temperature dia bagi tak? Dia bagi higher temperature 650. Saya tekan lagi kalkulator. 650 tambah 273. Walaupun saya boleh congak, tapi saya tetap tekan kalkulator. Betul 923 Kelvin. But dia tak bagi kita temperature dekat 4S, 5S. Of course 4A pun dia tak bagi, 5A pun dia tak bagi. Dia tak bagi kat kita. So how to find? Macam mana nak cari dia? Macam ini. Cara dia ialah, of course, from the first step, you kena selesaikan di sini dulu. You kena cari T2A dulu. Okay, T2A. Macam mana nak cari T2A? Remember the formula? T2 divided by T1 equal to P2 over P1 lambda minus 1 divided by lambda. Okay, you get T2. So T2 represent here is T2S, not the T2 actual here. T2S, you dapat yang garis lurus punya. Formula ni untuk yang garis lurus, bukan you dapat yang di sini. So you dapatlah T2. Kalau based on the figure here ataupun the symbol that they use is T2S lah. So you dapatlah T2S based on this formula. You gunakan 290, then pressure ratio 8, lambda tolak 1. Bear in mind that lambda ni sentiasa berubah mengikut question, dan CP pun sama, dia akan sentiasa berubah. So 0.4 divided by 1.4, so you akan dapat T2S lah. Alright, T2S di sini you tak dapat T2. So nak dapat T2 macam mana nak dapat T2? Remember, untuk kompresor isentropic divide by actual. So kompresor T2S, T1, T2 actual, T1. Macam mana saya tahu T2S, T1, T2A? Saya depend on formula on based on this graph lah. Sini T1, sini T1, sini T1, dan sentiasa positifkan dia. So kalau T2S higher temperature, T1 is lower temperature, so T2S tolak T1 lah. Saya tak boleh lah tulis T1 tolak T2S. Dia akan dapat negatif. So T2S minus T1, dan actual T2A minus T1. You cari T2A ni. Tambah 2S, T1, kompresor. You dapat T2A. Once you dapat T2A, you boleh dapat terus work in daripada kompresor. CP T2A tolak T1. You dapat work in. Sebab apa kita cari work in, kita tak cari work out? Siap-siap. Sebab work out kita tak tahu. Kita tak tahu nilai pressure kat sini. Kan? Tadi you buat question yang tadi dia bagi tahu T4 ni sama dengan pressure 4 sama dengan pressure 1. Okay, pressure 4 sama dengan pressure 1. But this time pressure 4 ni dia line dia pun line yang lain. Line yang lain. Different line. Okay, which is actually pressure 1 is equal to pressure 5 and pressure 2 equal to pressure 3. Okay, pressure 1 tak equal to pressure 4. So you cannot use T3 divided by T4S equal to P3 over P4. Boleh tak you gunakan P3 over P4 ni equal to 8? 8 di sini? Tak boleh. Sebab line pressure dia pun tak sama, tak bersambung. So you cannot use the same pressure ratio. Okay, you need to find this pressure ratio. Apa pressure dia kat sini. Sebab tu soalan tu suruh cari T4A dengan P4. Kalau you senang-senang je terus masuk kat sini dapat 8, bukan soalan lah tu. Alright. So kalau you lihat balik soalan ini punya solution, dia cari T2A, dia dapat T2A di sini. Okay, kemudian dia terus kira work input, work in dari kompresor, dapat 295.5 kJ/kg. Kemudian daripada soalan di sini you baca, the compressor is driven by high pressure turbine and the low pressure turbine drive a separate power shaft, which mean high pressure turbine ni 100% work output dia digunakan untuk rotate compressor. So work in automatically, work in dengan work out untuk high pressure turbine benda yang sama. So ini ialah work in, ini juga ialah work out high pressure turbine. Okay, benda yang sama. So kalau kita tulis balik high pressure turbine, kita tulis balik formula untuk high pressure turbine work out, sini work out equal to CP gas kan, untuk expansion pakai gas lah 1.15. So T3 minus T4 actual. Okay, T3 minus T4 actual you dapatlah T4 actual. Sebab T4 actual you tak ada. Ini yang kita cari. Dia patah balik soalan tu, dia patah balik, dia suruh awak cari pressure pula kali ni. Okay, you dapat T4. Ini T4 actual 666 Kelvin, and after that you gunakan isentropic efficiency untuk turbine punya. Macam ni you cari yang isentropic temperature di sini 4S. Sebab you dah dapat 4A, nak cari 4S pula. Dapat 4S, you dapatlah sini temperature yang 4S. After that baru you boleh pakai formula yang ini. Sebab you ada T4S, T3, P3 dan P4, you not necessarily kena cari satu persatu. You boleh guna terus nisbah. Sebab tu digunakan nisbah ni, P3 over P4 equal to T3 over T4S. Masuklah nilai 923 dengan 620, dapatlah nisbah P3 over P4 ialah 4.9. Ok, nak cari P4, you tahu P3 berapa, dapatlah P4 1.65 bar. And then seterusnya sampai you dapat yang last di sini, akhir, sampai you dapat cycle efficiency di sini, heat supply di sini, work ratio di sini, net power output macam ni, macam itulah seterusnya. So basically what most important on this thing is you must understand the question and correctly state out what most important in the question and what represent those statement on TS diagram. As long as your TS diagram is correct, everything is correct. Okay, you don't have to worry about that. Once your TS diagram is correct, you need to find the temperature. Always find the temperature from the compressor and move on to the turbine side, which is one stage or two stages. Kalau awak lihat untuk soalan nombor 4 di sini, dia ada dia ada dua kompresor, satu low pressure kompresor, ada high pressure kompresor. Satu lagi ada high pressure turbine dengan low pressure turbine. Kalau kita lukis dia jadi macam ni lah. So sama juga, nak selesaikan soalan yang macam ni, you perlukan temperature at each position. 1, 2, kalau ada isentropic given, you perlu cari actual temperature dia. Then you can find the work in and work out, all the Q in and Q out. Okay, that's it class for today. You may try yourself. There's a lot of question here I given to you. Of course, saya bagi dalam bentuk PPT kan, PowerPoint kan, bukan PDF kan. So ini adalah salah satu, ataupun ada 5 soalan di sini. Ada 5 soalan yang you boleh buat pun di sini. You boleh buat. So cari power output, cycle efficiency, work ratio, dan dia ada solution dekat internet. You boleh tengok jawapan you, boleh compare. You boleh compare soalan dan jawapan you dengan apa yang ada dekat internet. Ada solution dekat internet. Sebab tu saya tak buat tutorial based on these problems. Sebab most of student tengok jawapan dekat internet, dia tak try langsung pun. Okay, you may try yourself, uji dulu pemahaman awak, then try compare your answer with the what as people answer on this problem, right? That's it for today. Any question you may ask me through WhatsApp, or I will answer it through WhatsApp, or if you need more explanation, I will answer during a class time. Right? Thank you. Assalamualaikum warahmatullahi wabarakatuh.